Hello dear students, we have a question. Let's read the question. The question says two small spheres of mass 1 kg each are connected to each other by means of an unstretched spring of force constant K equals to 100 Newton per meter, and natural length is given as 2.5 meter. The system is placed on a smooth horizontal surface and two spheres are given velocity is v0 as shown in the figure. First sphere, suppose the is given at a y axis, and another sphere m2 is given along the x axis, positive x axis. Then they are asking about the maximum elongation of the spring is also given, that is equals to 0.4 meter during the subsequent motion. And we have to calculate the value of v0 in the meter per second. We have to take root 31 equals to 5.6. okay. Now, dear student, we have to look over this only one figure, and that is going to be along the x-axis. That means in this figure, we have to neglect it, है ना? We have to consider this figure. If we are considering this figure, suppose this is a mass m, and suppose for a first time initially it is going in a positive x-axis, है ना? And it can go with the elongation of x equals to 0.4 meter. Okay, this is the elongation of the spring. And another thing is what, after some time it will be getting stretched. If the spring is getting stretched, then it will be returned into its original position. Okay. According to energy conservation, now what is the energy conservation says, if we have stretched into this way, then we will have half mv naught square. If with the speed of a v naught, we will have half mv naught square, and if it returning back to its original position, it will again lost that energy, half mv naught square, and both are in opposite direction, so we will have both as a sum. Okay, but while summing, we can have 1 by 2 m v naught square minus of 1 by 2. Okay, minus 1 by 2 m v naught square. So finally we will have final value of half, that is kx square. Okay, half kx square. Now we will calculate it, half mv naught square and plus again half mv naught square. That it will be getting 2 times of half mv naught square, that is mv naught square 1 by 2 equals to half kx square. And finally in this case we will have 2 times of 1 by 2 mv naught square equals to 1 by 2 kx square. Okay, so we will have mv naught square equals to 1 by 2 times of k, that is equals to 100 into x square, that is equals to 0.4 square. And mass is given as 1, and v naught is, we have to calculate, it will be getting 50, and 50 multiplied by 0.16, we will have v naught square equals to root of 8, 8, and it will be 8. And if v naught square equals to 8, and finally v naught equals to root of 8, that is equals to 2.82 meter per second. So for this question we will have a v naught in meter per second as 2.82 meter per second. So this is your final answer for this question. I hope you guys understood it well. All the best for this.